Hello, my name is Zachary Booker, and this is my second lab for Physics 2. For distributed charges, we are basing our data off our first lab with a, with a tape. And I forgot to include that I'm from the Georgia Institute of Technology, and I'm a third-year mechanical engineering major. So let's get on to the project. Here's our overview. As we've seen from class over the past few weeks, we were able to see that our first experiment was actually very representative of what happens with a real charged object. As we now know, charges are actually spread throughout an entire object, and we will now see how using this will change our system produced in VPython. Now, we have seen two different methods to solve for the electric field of charged objects. First would be the numerical method, which we'll be using today with Python. The other method, which I did not mention, is the more analytical method, please mathematicians, which is using integrals to solve for the exact value that the electric field should produce. Our procedures are the exact same from our first lab. We create a charged piece of tape by ripping it quickly off a base piece of tape. We have to ensure this piece of tape is charged by testing it with our hand. Then we could use a negatively charged pin that we use our hair to rub on to get that charge to observe that the charged tape yields a positive charge. And then we repeat these previous steps to make another piece of charged tape so we can make a bridge of sorts using a second piece of tape. Here's our assumptions. For the most part, our assumptions are the same from the first lab except for one big one that I added at the end. So, we would be neglecting air resistance, the possibility of our hands being charged. The entire tape would not be treated like a point charge this time. I forgot to remove that because my last line contradicts that, because now our new assumption we will make is that our charge is evenly distributed on the tape. What this means is that as you take off any little piece of the tape, or you just divide the tape into infinitely small little pieces, they will all have the same charge. So here are our constants. Our constants are for the most part the same, except for add the mass of the tape per meter, and the charge of the tape, because we saw for this in the previous lab. And there's a typo right there. It should be positive. The general idea of this behind this lab is using the idea of delta Y from the lecture. By splitting our tape into smaller and smaller chunks, we can get an idea about how much charge the tape actually has. For viewing purposes, I recommend splitting the tape into 50 different charge pieces, not charges. But if you want an even more accurate value of how much charge it yields, I would say split it into more parts. But using more around 50 will give you a good representation of what's happening vector-wise. Whereas if you use any more than that, the arrows will just be one big mess because there's just so many different vectors in the system. The solution method we are using is called numerical evaluation. So you can see from my lab, I inputting my constants into my code. You can see the tape length, the tape mass per meter, the mass of the tape, the distance between the two tapes when they separate it, and the charge of my tape, which I inputted another typo with a negative because on the second screenshot my charge is positive, but I made a mistake nevertheless, and this will be fixed in my encode. But as you can see, the charge is 1.17 coulombs, the magnitude of our force due to our previous charge. And we can see that the new electric field has increased by nearly 5 times. One very exciting finding I was able to conclude from this lab was that the magnitude of the charge increased from the representation of it as being a point charge. It showcased to me that this increase showed how there's more charge that's not being accounted for when representing the problem as a point charge. Another thing that I know is that the next charge force shouldn't change from the original, which meant that the new charge was greater, but it was distributed in a way that it would have a similar effect to the one for the previous lap. And thank you for joining me. It's been a pleasure.